Let's look at this question on graphing non-linear graphs. So the question is graph showing all relevant features of the equation y is equal to 2 over x plus 3 minus 2. Now this is an equation of a hyperbola. So you can do this in different ways. To draw the hyperbola, the first thing that you need to decide is the horizontal and the vertical asymptote. So the vertical asymptote is very easy. When would the denominator become 0, or in other words, when would the function become undefined? So whenever you have the denominator 0, the function becomes undefined. So that's what you're thinking first. So you're asking, when would this denominator become 0? Okay, so we'll ask the question, when would x plus 3 become 0? So it's pretty easy. When x is negative 3, the denominator becomes 0, so the function becomes undefined, which implies your vertical asymptote is negative 2. So what's the vertical asymptote doing? It's telling us that you cannot take this value. Okay, the function is not defined at negative 3. So you have to draw a wall there. I call that a wall. So let me draw a wall. So this is negative 3. So I'll draw a wall. So this is called the vertical asymptote, and this is called x, or the equation of this line is x is negative 3. So your graph will never touch this, will never approach this. So it can come as close as possible, but it cannot touch it. Okay, so I also call this line a don't touch me line. Okay. The next thing is to decide the horizontal asymptote. The horizontal asymptote, we can give formulas, but if you don't understand the intuition, you don't understand what's happening. So to find the horizontal asymptote, you're asking the question, what happens for the horizontal asymptote? So these are basically two questions you have to ask. For the vertical asymptote, you have to ask the question, when would the function become undefined? Or in other words, when would the denominator become 0? So for the horizontal asymptote, you have to ask the question, what happens when x is approaching plus or minus negative infinity? Okay, so two questions. So we can't do it together. So let us, in some case you can. But here, what happens when x approaches a positive infinity? That means it's a very huge number. So use your logic, put on your thinking cap. When I can say y, can I write y as minus 2? This becomes almost 0. So this is 2 plus, this is a very huge number. So this is almost 0. So 2 plus 0. So you can say 2 plus something very small. Okay, 2 plus 0 is, of course, minus 2. Sorry, minus 2 plus 0. So we can say when x is approaching positive infinity, your y would approach negative 2. Okay, it'll be negative 2 plus something. Okay, so you can say it'll never be 2, but it'll be 2 plus something. Okay, which is very small, so you can say it will be approach 2 from above. This is the notation to show that when x is approaching infinity, y would be approaching 2 from above. Okay, and what happens when x is approaching negative infinity? Y would be approaching, of course, negative 2, sorry, yeah, negative 2 from below. I'll explain this. Now, why did I write below? So here, when you put a negative number, this would become minus 2 minus 0, which is very small. So here, y would be approaching -2 from below. So I'll draw a vertical asymptote, sorry, the horizontal asymptote at -2. So this is your -2. I'll move this. So this is -2. Okay, that's fine. So this line is called y is equal to -2. So we can also find the x-intercept and the y-intercept. So the y-intercept is when x is equal to 0. So when x is equal to 0, so I'll show the working here. So y-intercept, it's very messy now. The y-intercept is when x is equal to 0. So you can say y would become, this is 0, 2/3 -2. Okay, 2/3 -2 is y is -1 and 1/3. Am I right? So this is 2 is how many thirds? 4/3. 4/3. So this is, sorry, this is 6/3. So 2/3 -2. So let us use the calculator. Why should we use our brain when we can use the calculator? 2/3 -2. We can do, this, my setting is wrong. I have to change my setting to a plus br. Yeah. So 2/3 -2 is -1 1/3. Yeah, that's right. So my y-intercept is -1 and 1/3. So this is somewhere here. Okay, so this is 0, this is 1, and so this is very close to, so this is your y-intercept. Okay, what's your x-intercept? X-intercept, so let me, x-intercept is when y is equal to 0. Okay, so x-intercept is when y is equal to 0. When y is 0, what will happen? 0 is equal to 2 over x plus 3 minus 2. So adding 2 to both sides, 2 is equal to 2 over x plus 3. So x plus 3 is 2 over 2. I hope you understand. This is 1, so x is -2. So your x-intercept is -2, comma 0. So the x-intercept is -2, comma 0. So these are the 2 points which will give you the shape of the graph. So here we know when x is approaching infinity, positive infinity, it will be approaching 2 from above. Okay, so it will be approaching 2 from above. So the shape of the graph, this would be when, of course I can also explain when x is approaching 3 from the right and left. Okay, I think it'll take too much of time, but you can understand the shape of the graph would go like this. So it will be approaching -3, sorry, yeah, -3. This is the x-intercept, this is the y-intercept, and this is approaching to -2 from above. This is what I mean. When as this becomes, the x value becomes bigger and bigger, this will be approaching 2 from above. And the other branch is a reflection of this, and that's what I'm saying, that when x is approaching a negative infinity, this will approach -2, it will approach y is equal to -2 from below. So this is the other branch. This is, I don't want to see this branch much, but you have to know the shape, and these two are symmetrical over this, or they are reflection of each other. Okay,